list, I will demonstrate the app that we've developed, which is basically the technical blueprint. The first work package is actually the analysis of the existing system. Which system? The system that is actually at the eMobility way to have. This work package is all about us trying to understand the system, trying to know the production side and the consumption side, the PV capacity, the battery capacity, the type of PV modules, the type of loads they have at the eMobility way to have. So we analyzed the technical data sheets of this electrical components that were provided to us by Siemens Stiftung and way to engineers. We actually had a lot of email conversations, exchanges with the way to engineers in order to synchronize ourselves. And then we actually employed Mo University to assist us in doing the on-site assessment because we couldn't go there due to COVID situation. And thanks to Mo University. And then after that, we developed some suitable assumptions in case of charging and running times of the existing loads so that we could simulate the system and see if the system could cover the existing load demand. And part of the outcome of this work package was that we found that, yes, the system was able to cover the existing load demand. And we were able to actually, we were able, to actually gather all the data that we've recorded in this work package in order for us to be able to expand the eMobility way to have. In this slide, you will see the overview, basic overview of the system at the eMobility. You will see that we have the PV and the PV modules. We have the batteries and the batteries inverters. And then you will see that we have, the loads. And by your right here, you will see some of the specification of the system. It's a 30 kilowatt peak system, 30 kVA PV inverter, battery of 104 kilowatt hour, and 18 kVA battery inverter. The next slide, actually, I will show you, the detailed information of the app, where you have the electricity production side. You have a 15 kVA genset, which is actually unused because the system is able to cover the existing loads. And you can see that we have installed PV capacity of 30 kVA with two 15 kVA SMA inverters. We have an installed central battery capacity of 104 kilowatt hour with three 6 kVA SMA batteries, which actually gives you the 18 kVA. On the electricity consumption side, you actually have the water treatment device, as Matthias mentioned. You have the water ATM dispenser that actually dispenses the water. You actually have the fishing lanterns, which are used by fishermen at night on the Lake Victoria for nighttime fishing. You would then actually have the internal lightnings in the hub and floodlights for securities and computers and other electrical devices, which are non-eMobility loads. So on the right here, you will see some of the pictures we were able to obtain during the on-site assessment by Mo University. You'll see here we have the PV panels, here the batteries and the battery inverters. Here you have some of the stuff from Mo University. You have the PV inverter, and here you have the lanterns. These are the floatable lanterns that are used by fishermen to fish at night on Lake Victoria. The next work package is actually the determination of the consumption loads. Okay, now, yes, we know the existing loads, the fishing lanterns, the non-eMobility loads, basically. So now we want to know the eMobility loads because they are the future consumption loads. So these eMobility loads were actually provided to us by Siemens Stiftung. We were one of the ones that selected this eMobility load. So we had actually the e-bikes. Basically, we had only two-wheelers. So we had e-cargo bikes, e-OP bus bikes, and e-border bikes. But there's no problem actually because our model can handle any type of battery-powered eMobility because what we need is actually the technical specification of that eMobility, just the battery capacity, the range, and stuff like that. And we're able to actually compile the technical system information of these vehicles, the distance, the speed, payload, the battery capacity, the charging rate, all this from the manufacturer's data sheet. And then, the resulting outcome of this work package was that we have technically documented the future loads at the hub. So now we know what our future loads, which are basically the e-mobility loads. Then we actually came up with a resulting research question, because initially in the previous work package, the system was able to cover the loads. Okay, so now I want to know if the system can be able to cover the future consumption loads. Meaning the e-mobility loads and the non-e-mobility loads. So these are our future consumption loads. So can the system now cover these loads? If yes, then good. If no, then how do we make the system cover this deficit? Do you actually oversize the technical system size? Or should you switch on the genset that was previously unused and pollute the environment? Or should you actually utilize the load management concept for load optimization and shifting? So this would be answered in the subsequent slides. Here, this slide is actually giving you the overview of the consumption loads